Hello! Welcome to a new section of the course, Supervised Machine Learning. This section covers the following topics. In this section, we will first cover regression analysis. We'll explore how to fit a regression model with LM and obtain the summary of the fit. Next, we'll use the fitted line to predict the value of a new instance. Furthermore, we can measure the prediction performance of the regression fit. We will then introduce generalized linear models, GLM, and demonstrate how to fit Gaussian and binomial dependent variables into these models. Moving on, we will cover classification models. First, we will build a classification model with a recursive partitioning tree. We will then visualize the built model and finally assess the performance of the fitted model in confusion and ROC metrics. Now let's start with the first video of this section, fitting a linear regression model with LM. In this video, we demonstrate how to fit the model to data using the LM function. Before starting, let's clear our basic concepts about supervised learning. The aim of a supervised machine learning method is to build a learning model from training data that includes input data containing known labels or results. The model can predict the characteristics or patterns of unseen instances. In general, the input of the training model is made by a pair of input vectors and expected values. If the output variable of an object function is continuous, the learning method is regarded as regression analysis. Alternatively, if the desired output is categorical, the learning process is considered as a classification method. Regression analysis is often employed to model and analyze the relationship between a dependent or response variable and one or more independent or predictor variables. One can use regression to build a prediction model that first finds the best fitted model with minimized squared error of input data. The fitted model can then be further applied to data or continuous value prediction. For example, one may use regression to predict the price range of a rental property based on historical rental prices. On the other hand, one can use the classification method to identify the category of new observations, testing dataset, based on a classification model built from the training dataset, of which the categories are already known. Similar to regression, classification is categorized as a supervised learning method as it employs known answers, or labels, of the training dataset to predict the answer, label, of the testing dataset. The simplest model in regression is linear regression, which is best used when there is only one predictor variable and the relationship between the response variable and the independent variable is linear. First, we need to download the house rental dataset from this link. When you go to the link, right-click and save, and make sure you save this file in the directory of RStudio. Also, ensure you have installed R on your operating system. Then we read the house rental data into an R session using read.csv command. Next, we fit the independent variable square feet and dependent variable price to GLM. Here's the output. Then we visualize the fitted line with the plot and abline functions. Let's use plot function. You can see the output over here. Then we use abline function to introduce a line. Here you can see the red line. The relationship between some predictor variables and response variables can be modeled as an nth-order polynomial. For instance, we can illustrate the second-order polynomial regression model in the formula y equals alpha plus beta x plus cx2, where alpha is the intercept while beta illustrates regression coefficients. Now we will see an example which will show how to fit Anscombe data into a second-order polynomial regression model. So let's start. We load the Anscombe dataset first. Then we make a scatter plot of variables x1 and y2 using plot function. You can see the plot function over here. You can see the scatter plot. Then we apply the poly function by specifying 2 in the argument, like this. Here's the polyfunction that we have described. You can see the scatter points are joined. Excellent. So in this video, we learned about regression model and fitted a regression model using LM. In the next video, we'll summarize linear model fits.